Hello there and welcome to today's class. For today, we'll be discussing or perhaps solving a typical problem under differentiation using the concept of first principle method. So the concept says find the y over the x or changing y over changing x for this man here. So how do you solve this? Using the concept of first principle. So we said from the idea of first principle, what do we know? We said to y, you had what there, changing y, to x, add changing x. So my first task here, using first principle, we said to y, add change in y, equal to this one all over root, I can see x here, of course, add change in x. I'm here. So the idea there is that to this y, add change in y. Next up, to this x, add change in x. Obviously, from here, I will take this y, other side here, I'll have that change in y is equal to 1 over root x plus change in x minus y. Why is it minus y? I just took plus y. Other side here becomes minus y. At this point, but y was equal to, what's y? 1 over root x. I have 1 over root x as the value of y here. So, but y, what's y? 1 over root x. So we are here. It means that anywhere I see y, I'll put in, or perhaps substitute 1 over root x as the value for y. So from here now, from this man here, change in y is now equal to 1 over root x plus change in x minus y. What's y? 1 over root x. So at this point here, I can see two fractions and a negative sign in between them. Now look up. If I have a fraction a over b minus c over d, these are two fractions, Abi. I can see minus there. Either minus or plus. What comes to mind? Looking for what? LCM. Now in this case now, I'm seeing two uncommon terms. So what's my LCM here? The 2 becomes what? My LCM. So I'll have that change in y is equal to, what's the LCM? We said the 2, Abi. Pick out this one first. That's root x into root s plus change in x. Look up. If I divide root s plus change in x here, divided by this one, that's 1, Abi. So left is what? Change in x. Change in x times 1 is what? Root x. Perhaps, sorry, if I divide this one by this, I'll have this root s left. Root s times 1 is what? Root x. Minus. If root s cancels root s here, left is what? This man here. This man times 1, it becomes root x plus change in x. At this point, I'm here. Obviously, my next task says that, hang on, look up here. My next task says that I'll rationalize numerator, please. So next task here, rationalize what? The numerator. So from here, rationalize from the concept of rationalizing. We said I want to rationalize what? Numerator, Abi. I'll multiply numerator and denominator by what? The conjugate of what? Numerator, right? So it means that change in y is now equal to root x. I have my root x here minus into root x plus change in x, right? All over what? The root x into root x plus change in x. I'm here. Now we said to rationalize numerator, we said multiply numerator and what? The denominator by what? By the conjugate of denominator. So what's my conjugate here? Times what? Root x minus plus, Abi. So plus here, because I'm rationalizing this one, take it to plus. That's the conjugate of this man here. Into root x plus change in x. Multiply this man here too. That's root x plus into root x plus change in x. I'm here. Look up, please. Oh. If I have a, look up, oh, if I have a plus b, or perhaps a minus b in this case, my answer becomes a squared minus b squared, right? So if I have a square of something minusing square of another thing, I have this as my answer. So it means that if I have a and a here, the same thing here, I have plus or either plus or negative. I have plus and minus. Look up, this is the principle. If I have the same thing here, the same thing here, and I'm having either plus or minus, my answer becomes what the that first thing all squared minus that second thing all squared. Look up from this idea now. I can infer something from this one. I can see root x and root x here. True or false? True. I can see root x between x all roots and this one here. True or false? So this is like A, this is like B. So it means that if I want to solve this one now without going through stress, I'll just say that change in y is equal to this is like A. Well, how about the a squared? So how about the root x all squared, right? Minus, because I'm saying minus and plus because minus b. What's my b in this case? That's what root x plus change in x, true or false, all squared. So it means that if I expand everything here, I'll get back to this. So shortcut, please. So all over what there, I can say what root x into root x plus change in x. Next up, root x plus into root x plus change in x. Of course, from here, square cancel out square, true or false? True. This man cancels this, Abby. So I have that change in y is equal to x minus into x plus change in x all over root x into root x plus change in x. I have this into root x, next up, plus root x plus change in x. I have this. Look up, please. Obviously, what's my next task here? My next task here is to what there? Use this minus to what? Open the bracket. So I'll have that change in y is equal to x as this x, minus times x is what? Minus x. Minus times plus change in x is what? Minus change in x. True or false? True. So all over, I have my root x into root x plus change in x. Next up, into root x plus root x plus change in x. Look up, please. I'm here, right? So of course this man cancels this. True or false? True. If I have a minus b, that's a minus a, that's what? 0. Plus a minus a, that's 0. 1 minus 1, 0. A minus a, 0. Similarly, x minus x is what? There 0. I'm left with what? Minus change in x all over what there? Root x. Of course, I have that change in y, please. Is equal to root x into root x plus change in x. Next up, root x plus plus root what the x plus change in x. I have this. Obviously, we said at this point, what do you do next? After you have look up, please. After you have changed what to y, change x to x, what's the next task? No, before that. Exactly. Next task is what? Divide through by what the change in x. First task, after taking y to the other side, you solve. After solving finish, what's the next task? Divide through by what the change in x. So at this point here, divide by change in x. By change in x. It means that change in y, this man here, is equal to what the minus change in x all over what the root x into, please call for me. All right. Into root x, next up, plus root x plus what the change in x. I am here. I have this. So we said divided by what? Change in x here. Next up, change in x. True or false? So it means that I have over 1 here. Abi? So now to change this one to times, so like there, I will invert. This becomes times. I have this one to be what? Here. I have my 1 to be here. True or false? Of course, from here, this one cancels this. So I'm left with minus 1, Abi. So change in y over change in x, which is the same thing as what? the y over the x. True of us? All right, it's now equal to minus 1, abi? All over what there? Root x into root x plus change in x into what there? Root x plus change in x. So here, from here now, look up please. From here now, what do you do next? Is that the next step? Okay, look up please. From here now, look up. I remember changing x. We said whenever you divide by changing x and you are still left with what? Changing x, you what there? Take limit of changing x to what there? 0. So I'll take limit of what? Changing x to what there? 0. That is, anyway, changing x here, you put what there? 0. So then that's my change in y, but what there? Change in x is equal to minus 1 all over what there? Root x into root x plus 0. Next up, into root x plus 0. Right here, let's get an answer, please. My change in y over change in x is obviously what there? Minus 1 all over root x into root x. True, right? Next up, because root x plus 0 is what? Still root x. I have into what the root x plus what the root x. I'm here. So from here now, look up. From this man here, all right, from here, look up this. From here, I'll have that changing y over changing x is equal to, look up, minus 1. I have minus 1 all over, please look up, root s times root x is what there? Is what? Root s times root x is what? Root x squared, abi? So it means that I'll have what there? Root x squared. True or false? But I know that square cancel out square root, abi? So from law of sword, if I have root a times root a, what's my answer there? A, yes, because I'll have root a squared normally, abi? Such that square cancel out square root, abi? What's my answer here? A. So the idea is that if I'm having a root of something times root of that same thing, what's the answer? That thing. So my idea is that instead of writing this one, if I have root x times if I have root x times root x, what's my answer there? X. So my answer here becomes x. Next up, I have a bracket here, abi? So a bracket, look up, root x plus root x is what? 2 root x. If I have a plus a, that's what? 2a. So if I have root x plus root x, that's what there? 2 root x. So it becomes 2 root x. True or false? Look up, please. From here, changing y over changing x is not equal to minus 1 on all the x. Look up, look up, look up. I have 2 in the middle of what? Alphabet. What I say you should do first? You bring out what? The number outside before the alphabet. So it means that it's correct, but not proper, please. So pick at the number first. I have 2. Next up, I can see what the x times what? Root x. True or false? Now, from indices, look up. From the idea of indices, from what you know, if I have x to power 3 times x to power 4, what happened in this case? I'll add the power, right? They are the same, abi? Pick out 1 and what? Add the power 3 plus 4. What's x, please? To power 7, abi? I apply this idea here. It means that if I have x times root x, I'll have that changing y over changing x is equal to minus 1 all over